So in this video, I'm going to go through an example of translating between different representations of a chemical reaction. I decided to use as my example going from a statement to an equation and then to a particle diagram, because I think that's the hardest one to do since you have to figure out the formulas. So when you do these problems, you're going to need a periodic table and a formula sheet handy. So as I look at this statement, I'm going to break it apart piece by piece. So I start with copper. Now copper shows up on the periodic table, and its symbol is just a Cu. So that's all I need to write for that copper. So it says copper and. So I'm doing a plus sign after the copper. That tells me I'm going to put a new chemical or a new formula next. So this copper and 4 hydrogen nitrate. So that 4 tells me my coefficient. But to get to the formula, this is where I'm going to need the formula sheet. So I looked it up. Hydrogen is +1. Nitrate is -1. So I'm not going to need any subscripts to get my formula to work out. This is just going to be HNO3. So the next thing I have in my statement is react to form. So that tells me that chemical reaction is happening, and I'm ending up with something new. So I'm going to do my arrow to show I'm going from my reactants to my products. So next up, I have copper 2 nitrate. So this copper 2, whenever I have a number in the name, that means it's got a particular charge. And copper 2 has a charge of +2. Nitrate still has a charge of -1. So that means I'm going to have to do 2 of these NO3s. And so I'm putting my NO3 in parentheses and putting a 2 subscript after that whole thing. All right, so then I have a comma, and it says I have 2 nitrogen dioxide. So I'm going to do a plus to get my next formula. I'm going to put a 2 in front. And then that dioxide means there's 2 oxygens. And that prefix, that di, is on your formula sheet, though we're not going to do a whole lot with those. And then I have 2 water. So I'm going to do 2, and then water is always H2O. Now for the particle diagram, I like to draw a line to split up my workspace. So I'm going to do my products or my reactants on one side and my products on the other. So I have to do a little circle for each atom. So I've got my Cu. Now, in this formula, I have one H, one N, and 3 O's. So I'm going to draw all of that stuck together in a clump. Doesn't matter how that clump is arranged as long as I've got one H, one N, and 3 O's. But I've got that 4 as a coefficient, which means I need 4 of these clumps. So there's 2. And I'm making each clump have 1 hydrogen, 1 nitrogen, and 3 oxygens. And there's my last one. So now I'm going to go over to the product side. So in this first formula, I have Cu, and then I've got NO3, but I've got that extra 2 subscript at the end, which tells me I've got this whole NO3 twice. So I drew one N with 3 O's attached to it, and then another N with 3 O's attached to it. I could also think of it as drawing 2 N's and 6 O's, just depending on what makes the most sense to you. Alright, so then my next formula is an N with 2 O's attached to it, and I've got that 2 as a coefficient. So I'll make another one of those. And then I've got my H2O. And I've got a 2 coefficient, so I'm going to draw that again. So there you have it. I've got this single chemical reaction represented in 3 different ways, with words, with an equation, and with a particle diagram.